Hi, everyone. Welcome back to our next science lesson. Today, we will be working on lesson 2.3, which is reading about phases of water. Aha. Okay, so let me share my screen with you. Okay, so far, what have we learned when we observed a cup of ice in a plastic bag in Where the Water Drops Come From, investigation 2? So we learned that the water droplets did not form because the ice in the cup actually cooled down the air in the bag to match each other. So when the air temperatures match, you're not going to get that condensation. Why did the water vapor condense on the cups in our investigation? We found out that the air temperature was warmer than the cold cup, and so that's where that forced it to turn from water vapor to liquid water. So we are still investigating this question. How do raindrops form? And we're going to be taking a look at our water encyclopedia today. So what I'd like you to do is, I think your substitute passed out to you the water encyclopedia, but if not, you can grab one of those. I'm sure I'll put them on one of the counters. And I'd like you to turn to pages 20 and 21. So I will wait a moment while you get your water encyclopedia. And there'll be enough for everyone to have. So go ahead and open it up to 20 and 21. Let's see. Oh, no. Turn to pages 20 and 21 in your notebooks, and then 20 to 29 in your water encyclopedia. It's titled Phases of Water, and you will be answering two questions in your water encyclopedia or in your notebook. In your notebook, you will answer the questions. Hold on one second. Let me pause for just a moment so I can make sure I have everything I need. Okay, thank you. I am now ready. Okay, so here is investigation page 20. So you're going to read Phases of Water in the Water Encyclopedia, pages 20 and 28, and answer the two questions below. So draw what is happening at the nanoscale in the diagram of the next page. Nanoscale means you're looking at it almost like through a microscope, like very, very small. Describe water molecules when they are in water vapor. So you're actually going to look at the diagrams and describe water molecules when they are in liquid water. So you're going to answer those two questions. And then, and then it says, in the nanoscale zoom in, you will draw and label the molecules of liquid water in the cup, draw and label the molecules of water vapor outside the cup, and draw and label the molecules of water condensed on the cup. So I think they just want you to answer the two questions first, and then you can do the next one. So I am going to give you 15 minutes. You're going to read by yourself 28 and 29, and then I want you to answer these two questions and then draw what you're seeing in the nanoscale view. Nano means really small, so this is a very small view. All right, I'll pause my recording and we will come back in about 15 minutes. Pause your recording too. Pause the video so that you can come back when you're done. Okay, welcome back. So now I'd like you to turn to page 25 in your water encyclopedia. I'm going to read this to you out loud. Molecules of water. I'll give you a moment to get to page 25. Water is made of water molecules, which are very, very tiny individual water molecules as are far too small to see. In fact, even 1 million water molecules clumped together are too small to see. A single drop of water contains around 100 million trillion water molecules. Though we can't see individual water molecules, we can see groups of water molecules when there are enough of them and they are close together. Imagine a speck of dust on the floor. You may not be able to see one speck by itself. However, if you sweep the floor, you gather all the dust that was spread out across the floor and end up with a pile you can see, collect, and throw away. This says this water droplet contains trillions of water molecules like the one shown here in zoomed in form. These water molecules are represented with red and white circles. So this is what a water molecule looks like when you look at it at a very, very nano scale. So now the next word I want to teach you is molecule. Will you say it in your head? And this is a group of atoms joined together in a particular way. So, what ideas do you have about what nanoscale is? Well, very, very small, a way of seeing it at a small scale. So, the water droplet, or the water drop is something you can see or observe, but the individual molecules are at the nanoscale. All right, so from now on, we will be thinking about what is happening at the observable scale, which we can see, and what is happening with molecules at a nanoscale, which is too small to observe the activity. Okay, so now we are going to be exploring the Earth system simulation. So the first question we ask is, what do you think happens to water molecules when water vapor condenses into raindrops in the atmosphere? So today we're going to use a digital simulation or sim to learn more about how raindrops form, both at the observable scale and the nanoscale. You will have time to explore the sim in pairs, and you will then use the sim to observe how raindrops form. So we're going to be answering this question. What do you think happens to water molecules when water vapor condenses into raindrops in the atmosphere? So today we're going to use the digital simulation to learn more about how raindrops form, both at the observable scale and at the nanoscale. So guidelines for using apps. Only one person drives at a time. Anyone can make suggestions about how to use the app. Talk about what you observe and rotate the role of driver. And actually, I think everyone's going to be the driver on this. So what I'd like you to do is open the Earth System Sim. And this says, go to the student apps page in your bookmarks. Scroll down and click on the Earth System unit. Click the orange box with the 1 to access sim and explore it. I may have different instructions for you shortly on how to open up the Earth System sim. I think we might be going into Clever and then into Amplify and Science and go from there. So you're going to explore the sim and think about your observations. All right, and think about what you observed during this sim. Okay, so let's see if I can play the first one. I'm going to play that again because I think you don't have the sound. So let me try again. Okay, you should have the sound now. This is going to show you how to do the sim.
This is the Earth System Sim. We will use it to learn more about how raindrops form, both at the observable scale and at the nanoscale. In the landscape screen, choose one of 12 landscapes. Each landscape shows the ocean and the land from a side view. You can also see under the ocean and underground. Control the wind by blowing it to the left, to the right, or by turning it off. Toggle water molecules on to show what is happening to the water molecules. This allows you to see what is happening to water molecules at the nanoscale, which is too small to observe otherwise. When water molecules are visible, a key appears. Blue molecules represent liquid water and pink molecules represent water vapor. Press Analyze to see more information about what you have observed happening in the sim. In Analyze, play back what happened during your run. Drag the atmosphere window to the landscape to zoom in on water molecules. Select a molecule to track it as it moves. This sim will be very useful in our investigations into water phases.
Okay, so I'm going to want you to investigate that and play with the sim. And I'll also put the, I think I'll be able to put the different sim explanations in there so you can look back again at that, because it's important to kind of play with the sim. So what is a sim? It's a model, and a model is something scientists and engineers make to answer questions about the real world. So the sim and the globe are both models. A model is something scientists and engineers make to answer questions about the real world, as I just said. Now, how is the globe an accurate model of the Earth? Well, it shows the right perspectives and where the continents are. And how is it inaccurate? Well, it's certainly not the right size, right? Okay, so now the sim is an accurate model in some ways. For example, it shows water flowing down from the mountain or into the ground where it is stored as groundwater. Oh, this could help us with our East Ferris, West Ferris problem. And it says, how is a sim an inaccurate model? Well, depending on what scientists and engineers are using for them, models show some of the aspects that are real world, but some of the aspects aren't there. So liquid water and water vapor are depicted with two different colors, blue and pink, respectively. But in real life, they're not two different colors. We just need to be able to see the difference. The color distinction in the model enables such students to distinguish between liquid water and water vapor. In reality, this is not what the molecules really look like. The molecules in water vapor and liquid water are the same. The difference between liquid and water vapor is the arrangement and behavior of the water molecules. Molecules in water vapor are spread apart. Molecules in liquid water are close together. So some areas in the atmosphere in the sim do not show any water vapor molecules. In reality, water vapor is everywhere. So they're not showing it on purpose so that you can really get into the sim. Okay, so I will provide further instructions on how to get into the sim. Okay, now, I am going to give you about 5 minutes to just access the sim, start looking at it and playing with it a little bit. And I will be back in about 5 minutes. You can press pause on your video. I will press pause on mine, and then I will give you an actual task to do in the sim. All right, I'll be back in a moment. Okay, welcome back. Remember, don't be stressed. Every time there's something new, don't worry. We're just going to do the best we can. So, investigating condensation. Would you please turn to page 22 in your investigation notebook? Okay, your goal is to use the sim to investigate condensation and then answer the questions. So, step one, you can choose any landscape you want. Then in run, check that wind is off and water molecules toggle is on. Observe the movement of the water molecules. Now press analyze, then replay to make further observations. Select a water molecule that has formed part of a raindrop. Observe the path of the molecule as you use the slider to scroll back and forth in time. Pay close attention to what happens as the molecules condense to form raindrops. Now remember, I'm just going over these so you can come back and look at the directions. Make sure you go in order. And then find a place where a lot of liquid water is forming in the atmosphere. Use the atmosphere window to zoom in on the molecules and see what happens when water vapor turns to liquid water. So these are the questions you're going to answer here. Describe the water molecules in water vapor before they condense into liquid water. What happens at the nanoscale when water vapor condenses into liquid water? And then does all the liquid water in the atmosphere fall as rain? Why or why not? So those are going to be the ones that you answer as part of the investigation. Okay, so with the remaining time, we're actually going to start with this in the next lesson. I can see that you're going to be running out of time. So what I want you to do is with the sim, I want you to try to follow these steps. And you might not get to answer the questions yet, but that's okay because we're going to start the next lesson with this and then move on because I can see that you don't have that much time left. You don't have more than 15 minutes left by my clock. So do your best with this. And in the next lesson, we will start with this. Okay. All right. Great work today. And I'll make another lesson for tomorrow. All right. Bye for now.